Hi there, and thank you for joining this session on actuarial models as API-backed calculation engines. I'd like to take a second and thank our sponsors for this event, and also to provide you with some important antitrust language. Awesome. So, as I said, sessions on actuarial models as API-backed calculation engines. My name is Marshall Tilley. I work for Life Innovators. My experience was working in life and annuity pricing and product roles, starting at MetLife and then Bright House Financial, uh, working in a life pricing and test tools role, building actuarial models for pricing and product calculations. Then I worked with FIS for several years in professional services for the profit actuarial software, uh, just helping clients to implement profit and build their products in it. And then now I work for Life Innovators, where we lead end-to-end product development for maybe a dozen carriers, building models, designing contract mechanics, and implementing these products and solutions with their various technology partners, whether that's an admin system, an illustration system, a new business portal, whatever that may be. And this is across a range of fixed, index, variable products, life and annuity. In that time, I've seen a pattern where actuaries build models and then vendors rebuild those models. And the ownership of the logic gets diluted. It's scattered across several systems and different coding languages. Maybe it's in an Excel sheet as well. And we have a hard time tracking down what the source of truth is and then distributing that out to all the platforms. And this session is about reversing that pattern and allowing actuaries to take back ownership of the calculation logic and using APIs as that mechanism. APIs are no longer a niche technical choice. It's likely most of us have heard the term API. Some of us may have a really strong understanding of what that is. Some of us may not know the specifics. But they're really common in banking, trading, payments, and the broader financial services. APIs are the backbone of how we communicate online a lot of the times. We may not even know it. Insurance is moving that way as well. Claims, policy admin, distribution, and agent tools are all starting to become this API first. And we'll get more into what that means. As actuaries, a lot of times we are passing files through email, over shared drives, file servers, however we can do it. And that works for a lot of situations. But there's some breakdowns where that doesn't work. Um, and those breakdowns occur with these manual exchanges and also this rebuilding that we've talked about. Um, with an API, we can enable all of our calculation logic to be called from a centralized source. And really, that should be our goal. We can test that central source and know that's the source of truth and branch out. We have illustrations, valuations, pricing, admin all running on different systems today. Most of us do. And that doesn't have to be the case. And it's going to take time to bring all that into a central source. But this APIs is a way that we can start to build that future. And a shift to API-backed calculation engines should allow actuaries to sort of own that future. These numbers help to show how API adoption isn't theoretical. It's the operating model for most major enterprises. We have 88% of companies use APIs for core business functions, and it's part of their core workflow. And financial services specifically, 70% of developers are increasing API usage year over year. So this is a growing business. And it shows us where integration, automation, and distribution of logic is heading. And by 2026, more than 80% of enterprises will will have generative AI delivered through APIs. And a lot of the times when we talk about how we can use AI, APIs is going to be the central piece of that because we actually need to pass real information, not just this language model, but this language model needs to be backed by something, and the API is oftentimes the answer to that. So for actuarial teams, the takeaway is simple. The rest of the business is already moving in an API first world, and we need to be aware and consider whether our calculation engines need to meet that expectation as well. And despite all this enterprise level adoption that we just saw, actuarial teams still operate sometimes like API adoption never happened. And so I'm going to walk through the problem from one perspective that I see it from. I think there's probably many ways this may really be a new business systems framing of the problem, but hopefully it resonates with you and your workflow. Um, each step of this process is going to be necessary, but the handoffs add time and increase the chance that the logic drifts away from what we intended. And this is an environment we work in an environment where speed, governance, and ownership are going to start pulling against each other, and maybe APIs can help us bring that back in. But to start with the problem, we start with model creation. So as actuaries, we build core models, whether they're in our pricing or valuation software, or whether they're in Excel examples. Whatever the platform, this is where the logic first comes to life. And then from there, these models get reviewed, they get validated and signed off on. And at this stage, the logic is, at least in theory, is stable, trusted, and considered the source of truth. Hopefully, many of you have robust testing software that are testing logic that allows you to say this is the source of truth. The extent to which that is true from company to company may vary. Um, but at this point in time, things work the way we expect them to, at least in our minds. The third step here is a vendor translation. Uh, this is where we have technology partners that rebuild our logic into production code. And really, if we look at our productionalized actuarial software, a lot of this works this way as well, where we have very basic ways of inputting a logic that gets productionalized into code. And when we talk about systems, a lot of times that means taking our Excel calculations and recreating them in code, or taking a Word document spec and translating that into code. And we start to get some breakage here between this internal testing and this vendor translation because it's been recreated. And that leads us to our next step in the cycle, which is testing and deployment. So we have teams of either actuaries, business analysts, all sorts of people who will reconcile our internal testing and our external results before the product launches. And between this translation and this testing and deployment, I've personally seen timelines extended for product launches, and there's different things across the array of actuarial world where this translation and testing is taking up a large amount of time. And that doesn't even get us started on our last step of the process, which is the maintenance loop. As we update rates, as we have features that we tweak, and we update assumptions, we have to retest, and we just start the cycle over again, all the way back from model creation sometimes. And that extends our release timelines, it extends our update timelines, and it increases budget. So this is a version of the problem. And it leads me to the bottleneck paradox, which is really the paradox that we live in as actuaries, where we are the experts. We design the products, we build the models, we set the assumptions, and we understand the mechanics better than anyone else. And so nothing really can move forward without our sign off. But at the same time, the central role is what creates the bottleneck, because any changes to rates, assumptions, features, anything that impacts calculations require our models to be updated, revalidated, and handed off, and then oftentimes rebuilt in another system, whether that's exposing this to distribution or exposing this to the admin system for calculation, etc. And the reconciliation process restarts. So actuaries have become both indispensable and they're the gating factor. And it's not because they work slow, but it's because the architecture that we work under forces everything through us, but the tools that we're using aren't meant to scale in this way. And so the paradox is the reason that API calculation engines matter to me personally. They let us keep the expertise and the ownership without becoming the constraint, at least lubricating those wheels to reduce the number of handoffs that we have. So throughout the course of this presentation, I will be referencing this ABR claim calculator, This is a generic example that is just sort of a Excel sheet that would be used to calculate an accelerated benefit rider claim. And what would often happen would be that someone would receive a request in some claims office, and they would send this to an operations team at a carrier. They would then send this over to Actuarial, who would review the calculation. They would create the spreadsheet. They would produce the values. It would go all the way back to that claims office, who would then maybe ask to verify the spreadsheet. And maybe this claims process would take a month to get this Excel sheet to produce a value that could then be sent to the client, or it'd be offered to the client who could either decline or accept that value at that point in time. So this is a sort of bottleneck that we often see in our industry from various partners. It's not always claims. It could be valuation results. It could be an array of things, data that we're passing back and forth uh, for assumption studies, experience studies. There's all sorts of situations where this could occur. I'm going to use this as a demonstration for this presentation. I'll just kind of tee that up here and we'll return to it later. So an API call. Let's start there. Think of an API call as run this calculation with these inputs and give me these outputs instantly. That's all it's really doing. It's just a calculation engine that's surrounded by inputs and outputs. And we'll see this diagram here with the JSON. That's a data type that that we're going to reference here. So we have our inputs are coming through as JSON. We have a calculation engine wherever that lives, that runs on a server somewhere, and then we receive outputs, which is another JSON. API stands for Application Programming Interface, and it's a set of rules that let one system talk to another. And it defines the formats of the inputs and the structure of the outputs, and the rules are for how do we assess the calculations. And in our world, that might be a pricing engine, an illustration tool, an admin system, a claim spreadsheet, for example, or even Excel talking to a calculation engine. And we'll talk more about that as we go along. Um, but all this to say that we want to develop an API first architecture, which is something that all coding languages is starting to do. And it's develop an approach where APIs are designed, documented, and built before the front end user interfaces are developed. So before we even think about how someone's going to interact with our work, we should be thinking about how it can be interacted through an API. Common misconception here is that APIs will make us rebuild our models. For the most part, that isn't true. APIs shouldn't replace the models; they should just expose them. It may feel true because of our legacy technology that isn't allowing for API adoption, which is a huge and real barrier here. But the goal going forward should be to build models that can be used for API, and hopefully our various vendors share that goal with us. And the model should stay exactly where it is, and the API should just expose that logic so that other systems can call it. This will keeps logic intact with an API wrapper on the outside. It creates a single source of truth with better version control. So that way, as we update versions, we keep more of a code-like version control. Developers consume the calculations, and actuaries maintain the logic, which means that we can send this API to our web developers or to our data team, and they will just interact with the outputs and the inputs. They won't own the actual what happens in the middle. And this is really an excellent feature for things like rate changes or assumption updates. I think we probably all have some experience with things like this, where we make it really easy to change an assumption somewhere to get a new output, whether it's some sort of assumption manager that we use in actuarial software. A lot of times, and just coming from the new business world, rates are literally updated either like sometimes in the PDF or in the Excel sheet, and this has to be done several times. And I'm sure we all have processes like that where an API could easily feed that rate directly into the output and be exposed directly to the end user. When we talk about building APIs, there are some things that are good to know. We're going to talk about where to run the code in a share, lease, and own format. Think of this the way you would say a car, where you call an Uber, you lease a car, or you own a car. And you could probably take that analogy to several different ideas. Uh, but we'll thinking about APIs, to share would be to have a serverless API, and this is probably the most common option today. And this means that we're going to share cloud resources, and they'll scale automatically, meaning we can add additional resources as necessary because it's all shared. It's cost efficient, and it's ideal if we have like spiky workloads where we don't have constant usage, but sometimes we use it a lot. And so we don't have to pay for a lot all the time. We only have to pay for a lot when we use it. Sort of a pay as you go. Um, and this is again the most common strategy, but it can be a little slow on a cold start. There could be a delay on the first call, and then as we call it multiple times, it speeds up. There's things run quicker as the machine's already warm. Um, that particularly uh, pertains to the first call though. And then we could have the second option is to have a container. This is the middle ground solution. It's where you lease dedicated compute in the cloud. So you have compute that's assigned directly to you, and you have control over the specs of the compute, over the start time of the compute, and you get more predictable performance, but you don't have to manage the hardware itself. So you sort of get access to the settings, but you don't own the hardware, and you don't have the upkeep cost to host and to literally house the hardware. And then the final option is to own a virtual machine. And this is a more traditional route where you have full ownership. The machine is always on, it's fully dedicated for you to use and fully controllable. This is the highest cost option, and it has the most operational responsibility. Uh, it's necessary for certain use cases, things that need to be, if you're using a consistent amount of compute over a consistent amount of time, this is where companies will go. And this is where really talking to your IT partners will come in handy. But once you know where to run the code, and there's several options for that are not too difficult to figure out. But once you've figured out where you're running the code, the rest is really straightforward. Um, we're going to expose a public URL, which is going to be called an API endpoint that other systems can call. And that's going to look like a typical web address. Uh, we're going to write code in some sort of language that can send and receive JSON. I think Python might be the one that resonates the most with actuaries, but Node is another example. And there's plenty of languages, Rust or things like that, where you can call APIs relatively easily. And with generative language models, it's becoming pretty easy to get Claude code and to write these API calls yourself. I think that deploying those and hosting them, as we discussed earlier, is where you run into issues there. Um, there's an authentication step. There's an API key that works like a password to the endpoint, and so you'll need to sort of provide whoever is calling the API with this API key. There's other authentication methods. So this is probably the most straightforward. Um, and then there's all sorts of other operational practices that need to be considered: version control, performance tuning, logging errors and messages and things, and security hardening. Um, and all this is things to keep in mind. This is the main points of the entire architecture: a place to run code, an endpoint to expose it, a language to write it in, and controls to keep it secure and performative. Um, and once your model is exposed in this way, all the downstream benefits start to compound, and API really just becomes an easy win. So there's minimal learning curve to JSON in, or to this whole process with JSON in and JSON out. There's no new actuarial tools, and not necessarily a need for a new coding language. Your model should be able to stay where it is, depending on how you can access that through API. You're just going to be delivering results in a different way. One of the biggest wins is that you won't need to hire a team of developers to rebuild this logic if you can call your current logic through API. And the translation work, which is time and materials, is going to decrease. API simply calls the existing calc engine. The means that means that the math becomes instantly reusable across every team. So whether we are talking about pricing, valuations, illustrations, distribution, admin, reporting, we can all then pull the same logic where necessary. Maybe we don't all need the same logic, but it's oftentimes shared between multiple teams. And it's going to move the organization away from emailing spreadsheets or passing around Excel attachments, whether they fit or not in the email. The calculations become real-time services, which is how every other financial function already operates. And once the logic sits behind an API, you can build a UI, UX portals, dashboards, integrations, a PDF output, all sorts of things that you want to do. That without touching the actuarial models itself. And there's plenty of ways where actuaries can do that themselves. You can also trust your tech team to do that for you, knowing that you are owning the logic behind it. The front end becomes lightweight, um, where the model becomes the engine. And that's really the lightweightness is what what's easier to trust our technology partners with, because that's really what they're the experts in. We are the experts in the calculations. Um, and each function of this business benefits from this shift because of that. So we have actuaries who are going to own the production logic. We're going to increase the fidelity of our work and the speed that we bring it to people. IT is going to integrate and translate, and it's going to reduce their backlog because a lot of times this integration step is not that difficult for them in comparison to building all this logic. And then our compliance increases because we have actual access to the logic itself, and we can test it faster, and we can push it to production faster, and it becomes more traceable. We're not having to ask someone else to use their eyes to see what the code is doing. All right, so now we're going to return back to our API or ABR claim example, and we're going to show start to show how we can use Excel to implement an API. So every company, or most companies, I would assume, have powerful models in Excel or have the capability to build powerful models in Excel. The ABR claim calculator I showed earlier is a perfect example. It works, it's validated, and it's a model that everyone trusts, at least for the purposes of this example. The issue isn't the math that's in the model, it's how we're delivering the math. So we're going to talk about Coherent Spark, which is a tool that allows us to import Excel models through a website that generates an API. So you've already built the model, and all you need to do is to tag up some cell ranges that form the API schema. And it's going to convert named ranges and calculation blocks into that input and output of our API. And once that structure is set, Spark will package the workbook behind a secured API endpoint. And instead of emailing my ABR spreadsheet, I will be able to rebuild the logic effectively in the admin system or in some sort of portal that the math can be accessed directly by a user. And so maybe an admin system could build this, but it would take time. And given the the nature of the ABR claim, maybe my company has decided they don't want to spend that to invest that capital into building this logic. So we're going to talk about just a way to kind of bypass that by owning the calculation ourselves. And the real benefit to this is alignment. Actuarial, IT, and distribution all are going to use the same ABR model, same or operations, the same value. So we're all going to have the same validated model, and the calc's going to come live. There's not going to be any rebuild, no reinterpretation, no reconciliation cycle, just one authoritative calculation that everyone else connects to. So with that, I'm going to return to our demo. So what we have here is our Excel worksheet. And if we look in here, we see that we have X inputs and X outputs. Our output is this range right here, where you see our coverage amount and account value before and after claim. We also have our accelerated benefit amount output. And as I click on these, you'll see where that goes to. And we have all these X inputs, starting up here, we have X input product, X input issue age, all these fields that we're exposing in our Excel book. And if I grab this Excel book, I could figure this out over time, but it's going to be tricky, right? It's going to be tricky to figure out where the output is, where the input is. Um, we get the output tabs in green, specified inputs in blue cells. There's instructions here, but let's face it, we've all picked up workbooks like this that weren't completely intuitive, and they weren't built like user interfaces for sure. And that's where Spark is going to come in to sort of shortcut this process for me. Um, so I'm logged in here to my Spark instance, and I have this ABR claim calculator folder, and this is where my claim calculator lives now. So I've got the Excel book, and it is as simple as dragging and dropping my Excel book into here. And there's a translation process because this isn't literally hosting Excel, it's hosting some code in C that will control my API. As we wait for this to convert, you'll see that there's version controls. I can always go back and run a new version. I can put in a version label, and I can say this is my demo upload, and then release notes that say I uploaded this version for the demo, and an effective date. So I can have these calculations effective in the future, or just over the next 100 years, which is the default. And I'll publish this. There's some notes on all the cells with data. So this is a rather large workbook that I'm converting in a pretty quick amount of time to code. All right. And so we see here that I've got my API request here with all my inputs, the same inputs that we saw before. I have my products, I have my issue age, my sex, risk class, all the things we saw before. I can submit this and I can get that output table that we discussed. And I got that single value that I needed, which is great. So I've got my API here and I have my API endpoint here. So I just need to ask uh, someone to write code that can call this API endpoint, uh, provide this data as input as JSON input, and receive this data as JSON output. It's that simple. Spark has all sorts of tools in here that will help you sort of do that. So there's the Swagger, which gives an example of all these different fields, the types and the example, the default example. And there's also documentation that can be produced that will sort of give someone an opportunity to see like all the fields, the API endpoint, and all the information that you need. So that all exists. And what I've done here is I've taken this Swagger file, which I've downloaded, and I have fed it into Claude Code, and I have created this index file. And my index file here is referencing my API key and the uh, and the HTML endpoint that we just discussed. So if I open this up, I have here using Claude Code and the Swagger file built a user interface that works exactly like my Excel book does. So I can calculate an ABR benefit. And we get that extended runtime because of that first call on that serverless API. But I can easily, switch my election age, and you'll see my ABR benefit change. I can switch between products. I can change my fixed cost period. All sorts of things that will control the outputs I get. And now I have a fully processing ABR claims calculator This is a local file on my workspace, which would work. And I've worked at companies where user interfaces were shared locally, and you could provide this user interface as a standalone file that could could be called locally off your desktop, or this could be hosted onto a web page for more people to use. Um, but this is the basics, and this is something that I was able to build. It took me a lot less time to build this UI than it did to build the actual Excel sheet. That's for sure. Especially as far as testing and validation goes. This was actually a relatively straightforward process once I got everything built into Excel. And that's really the end goal is to get something that can convert Excel to APIs very quickly. Yeah, now you don't have to use Coherent Spark to take advantage of APIs. This is just a very practical example of how to take Excel, something that's what I would view as a common language, and to something that can quickly be transferred into sort of this user interface that everyone can use. Um, yeah, that's the basics of this demo. We've taken, our Excel workbook. We've built this code file that's sort of based on the Swagger file that we downloaded off of Coherent. We developed code that can then be called on user interface, and this is now live, hitting that UI each time that I do it. And I have not only do I have that, but I have the full. You can see over the last, hour or so, I've called this in the API tester. You all watched me do it, and I called it twice over our claims calculator website here. And I get my timestamp, I get my runtime, and I can also download my Excel file straight from here and see what was wrong. So now not only am I able to host my calculations live, I can also go through and check them live as well. So returning to our presentation, I'd like to discuss a roadmap to adoption. Uh, this is a pretty simple use case, and I think that's the best way to start. So the first step is really to pick a contained use case, something like an ABR claim calculator, or a single rate engine, maybe a product that um, updates rates regularly, and that's a manual process. It's a marketing material that needs updates to rates, things like that. The goal isn't scale at first. The goal is to sort of create APIs and integrate them into your actuarial process and learn more about how that works. Providing quick value with real calculations is a good first step. Um, to wrap existing Excel models or any model in an API. So this allows us to, we don't need to spend time rebuilding. We don't need a new code base. We don't need a month-long project to develop a calculation. We have something that we already use like this, and we can quickly turn it over. This can often be done in a day. As far as if you have the model working, getting it to an API does not take that much time. And the point is to show how fast models can become callable outside of Excel in this situation. And to integrate one distribution channel. So now we have our API. We need to find a single consumer who needs this API. And this could be a simple web UI, an internal pricing tool, sales portal, policy admin workflow that maybe has been manual. And this is where value becomes tangible. Just finding that one distributor. Ideally, you find a use case that has multiple end users, but focusing on one endpoint at first is a very good method. And ideally, we end up in a situation where we do have multiple users getting the same math and delivered in real time without touching an actuarial model. Where we really start to get, so at this point, once we develop the pilot, we want to start measuring the benefits and seeing fewer builds. The reconciliation cycle, really speeds up, and there's less IT backlog, faster delivery, and at this point, you start to scale with more products, more features, more channels, more use cases, really, and you'll start to see that the marginal cost of all of this really starts to really be outweighed by the marginal benefit. And this roadmap is intentionally lightweight. Like we don't want to make this hard for anyone. We don't want to, have an actuarial transformation project to start APIs. That's not really what we're talking about here. No system migration, no platform overhauls. You start with something that works, that you trust, and you expose it once and you integrate it once, and then you iterate. You start to find new ways that this is useful, and you start to save real people, real time, and make things quicker and easier to use, and a little more user friendly at the same time. All right, thank you for your time today, and please let me know in the chat if you have any questions. Thanks. Bye.